This tutorial describes the SIDLAB user interface and some of SIDLAB's basic capabilities. When you first bring up SIDLAB, you get this screen where it asks you to choose a task. Simulation is the modeling task, and acquisition and measurement is used with the SIDLAB acquisition and measurement system. If you choose acquisition and measurement, you then must choose between a one-port or a two-port measurement. In simulation, you choose between a low frequency or a high frequency model, and you also choose either a frequency range or an RPM range. And finally, you choose units, which are inches or meters or millimeters. Once you have made these choices, you click the next button. The next screen that comes up is the General System Data Management screen. You can see here that there are 6 icons. This is the existing management system. Over here is the CAD viewer. If you bring in a CAD model, you can look at it while you are creating your SIDLAB model. This is the network screen where you actually create the SIDLAB model. This is the solution screen where you run your model, look at results. Finally, there is also an optimization tool and a parameterization tool within SIDLAB. On this first screen, you choose your fluid data, which can be a gas or a liquid. Once you choose the gas or the liquid, SIDLAB will give you the default parameters here for that particular fluid. You can use these, or you can change them or create parameters for your own fluids. Up here to the right is the space for a project description or model names or whatever you want to put there. In the lower left is the version manager. Here SIDLAB keeps track of your different models and model versions. So you're allowed to create numerous models under one file name. When you bring that file back into SIDLAB, it will list all the versions and models you have here. You can recall those models by using this Use Version button, and it will bring up and you can continue working on those same models. To the right is a similar screen for Plot Manager. This simply keeps track of all the plots you have made and allows you to delete them or load them and look at them again. So this is the CAD viewer screen. If you had brought in a CAD model, this is where you would see it displayed. This is the network screen where SIDLAB models are created. And models are created simply by dragging and dropping these model elements into the screen. For example, we can drag in a pipe, we can drag in another pipe, and we can drag in possibly a third pipe. Once you have dragged and dropped these elements, you can connect them using the Connect button. And SIDLAB will also need a beginning and an end node. The beginning node is always the green node, and the end node is always the red node. In addition to dragging and dropping your elements, you have to put in the basic element parameters. In the case of a pipe, the critical parameters are length and area, so you must enter those. Or if you, for example, choose a diameter of 3 inches, it will calculate the area for you. And you can also put in your own length here. Now that the model has been created and you have filled in all the parameters, you go to the solution screen, and here you choose the frequency range that you want to use and the steps that you want to calculate those frequencies in. You can also change the temperature. The default temperature is 68 degrees Fahrenheit, but if you have, for example, a hot exhaust of 1000 Fahrenheit, you can put that in there. What that will do is affect the physics of the model. The hotter the gas, the longer the wavelength will be, which affects the design of your muffler. SIDLAB will also calculate flow for you, flow parameters. If you give it a mass per second flow rate, then you press the Calculate Flow button. Down here in Results, you can look at flow distribution, or the amount of flow going through each element, the flow Mach numbers, and the pressure drop, and it would also calculate if you want a pressure flow curve. Once flows are calculated, the passive button will show you the acoustic results. The acoustic results must first be calculated here after the flow, and after which you can look at transmission loss, noise reduction, insertion loss, and so on. Now you don't have to have the flow module to use SIDLAB. You can use strictly the acoustics module, but if you have significant flow through your system, that can also affect the acoustics, in which case you would want to have both the flow and the acoustics module. This we will not go into a lot of detail here, but it is the optimization screen where you can choose an element, choose a property in that element, and you can optimize a parameter subject to a series of constraints as you would in any type of optimization problem. Finally, there is a parameterization screen. If you don't want to optimize but you just want to see the effect of one parameter, for example, you choose a pipe here, you would choose the property which is length, area, diameter, whichever of those you want, and then you can have a starting point and an end point and a step in which you iterate on that parameter. Once you do parameterize, SIDLAB will then calculate all the solutions to that series of parameters. This ends the module or the tutorial for the SIDLAB user interface and capabilities.